Good evening, fellow scholars. My name is Faith Bratton, and I'm going to be talking about our Lesson 1 module for this week. Okay, let me go ahead and share my screen real fast. Let me get my PowerPoint going. Okay, so it's Chapter 8, Algebraic Reasoning, Graphing, and Connections with Geometry. And this is Math for Teachers 2. Okay, so for question 1, the question they're asking us is, explain and show a graph to correlate with the function of the amount of gas in a gas tank when a driver refills the tank of a drive across country. Okay, for this graph, we know that on the bottom is our x-axis, and I'm going to get a highlighter so we can go through this together. Okay, x is the distance traveled, which is on the bottom, and the y is the gas tank. Okay, so right here we know that where we begin on this line is because it starts right here, because this is where, if he's getting in his car at home or anything like that, or if he's at another gas station, he starts his drive and he decreases. He's losing gas, losing gas, losing gas. Well, this spot is where he's either stopping at a gas station or he's refilling gas, anything like that, and then it takes off again as he is filling up with gas. Then right here, when it starts to decrease again, is showing that he is on his drive again and he's decreasing in gas, because when you're driving somewhere, you're not gaining gas, you're not gaining energy. Okay, so for the next one is show and explain a graph to correlate with the function of the height of the elevator stopping at each floor. For this graph, we know that the x-axis is on the bottom, and it's the time of length the elevator has stopped. The y is the height to the next elevator, or the next floor. Okay, while we start right here is because we know we're starting at like the lobby or anything like that. We're going up because we're going up in floors, over because why it's stopping at that little level. It's because if the elevator's not being used, people are getting dropped off, joining on the elevator, anything like that. And if it was more rapidly the stairs, that would show that like maybe the elevator is being used more, anything like that. Okay, for this one is okay. For this graph, we're explaining to correlate a graph with the function of the height of a bouncing ball dropping from the top of a table. Okay, in this graph, we know that we see the line is going crazy. We know that our x-axis is the time of the ball, or the time of the ball bouncing. Then the height of the ball bouncing is on the y. Okay, why it's starting from such a high point is because if you look in the question, it says that the ball is bouncing from a high table. It's not coming from the floor, so it's starting from a high elevated area. Okay, as the ball is dropping, why it has such a big force at the beginning is because the force of gravity is pulling that ball down. And so it is making the force so big, and it's accelerating a bunch because of such the acceleration from the height. Well, then, as it slowly is going, it's losing the momentum and the force, and gravity's pulling that ball down more, that it doesn't have this greater speed. And so the weight of the ball is weighing it down, and so the time is going slower. Ball is slowly going at a speed that's not very fast. Finally, it'll come to a complete stop. Next, the question is to correlate and complete a graph talking about the height of this flagpole that the shadow will be. Just explain and show a graph to correlate with the function of the length of a shadow of a flagpole, throughout the sunny day. Okay, so in this graph, we know that the flagpole is making a loop. Why it's making the loop is because on the x-axis, we have the sun down, or sun up, time of the day, and the sun down. Okay, why this does this in the y is the length of the flagpole shadow. Okay, why it does this is because at the top of the sun up, the sun is rising. And so here's the flagpole. When the sun is rising, it's doing this. So the shadow is going to be on this side. It's going to be a tall shadow as the sun is going up. But when this time of the day, when the sun is at its highest, that's why the graph is so low. It's loose because the sun is at its highest point. There's no way that it can shine on the flagpole from a certain side to make the shadow tall. So the shadow would be short at the time of the day. But then when the sun goes down, it's going down again, so it's coming at an angle. And so then the shadow will be on the other side. Next. Okay, for this one, it is telling us that, okay, it says, suppose two function machines are hooked up in a sequence. So the output chute of machine G empties into input hopper of machine F. Select a couple of machines which is defined in the range of G is a subset of the domain F. It's called the composition of F and G and can be written Fx equals Gx. Okay, suppose F is tripling function 3x and then G is at 8. Okay, so what it's saying is that in this chart we're using the equation Fx equals 3x and G is to add 8. So first we're going to do the input. So whatever number we input, we're going to multiply that number by 3, then add 8 to it, and that will be our outcome. Okay, so they're giving us the numbers, and they want us to use 1, 2, and 3. So the input is going to be x, so we'll go ahead and draw x. Okay, and the output will be y. Okay, so then for this, our input is going to be, so we're going to use, we'll do like we just showed an example, Fx equals the input 3 times 1, where we just got this one and this one, equals 3. Then we add the 8, or then we add the 8, just as in the equation right here, to the 3, and we get 11, which is the output. So just as we did, the next one to be 3 times 2 equals 6, and 6 plus 8 equals 14, which is the output. Okay, it's just as simple as that. That is exactly what it's telling us to do. Okay, so okay. Okay, for question 3, it is telling us that show and explain the slopes of the line segments determined by the given pairs. In this case, tell whether the segment is vertical or horizontal, the slope is upward to the right or slopes downward to the right. Okay, compare parts. Okay, for number A, which is the first one we have right here, we have P is, the X is 3, the Y is 1, then Q, which is 5 and 5. So X equals 3 and Y equals 1 for P, and then X equals 5, Y equals 5. Okay, so we know that this line is straight going up. So we have plotted it here. Okay, so we plotted this here. We have 3, 1, 5, 5. So we plotted those. And to find the slope, we do this. We use rise over run, which is slope x or slope y over slope x to find the slope. Okay, so we know to use rise over run, we rise from this point, so we go until we can get even to the other one. So we go 1, 2, 3, 4. Put the 4 here. Then we go over 2, 1, 2. So you go 4 over 2, which equals 2. So slope equals 2. That was pretty easy. For question 3, still, now we're doing part 2, which is r equals 5, 8, and s is 5, negative 8. Okay, so for this slope, we're going to use a different one a little bit. Okay, we're going to do y2 minus y1, x2 minus x1. Okay, so we plotted our points over here. We know that the line is straight. We know that the line is straight, so we're going to plug in 5, 8 minus, and 5 and negative 8. So we're going to do negative 8 minus 8 over 5 over 8. Okay, we can see that this is a vertical line, and when we solve this, we get negative 16 over 0, which is undefined. So this slope is undefined. Okay, for question 3, we have u is negative 1, negative 4, negative 4, negative 13. So we're going to use the same thing we did before. Y2 minus Y1 right here. X2 minus X1. So we get negative 13 minus negative 4 over negative 4 minus negative 1. We get 9. Negative 9 over negative 3. We get m equals 3. And then this one, to find the slope, we use the same formula, and we plug in the numbers to get that. Okay, for question 4, it says, show and explain the graph each of the following functions and describe the similarities and differences in relations between the graphs. Okay, for mine, I use, for the equations that are given right here. For mine, I did negative 5 to 5. You can use any number to plug in. This is just the range I use. You can use any range. You just have to know that x has to follow the functions of the given formula. With the given formula, we can add in any number to the problems of the parabola. Okay, so we work this out, and you plug it, and it really works in Excel very good because this is where I got this chart from. Okay, so for this one, we did negative 5, and if you plug it into the equation, you get 25. You plug it into the equation, you get 112, 18. This first one is the lowest one. This column is the second line, and the third one is this one. And it's plugging these numbers that are in the x into the x in the equation of the variables, and plugging them into the variables and finding out the answer and plugging them into the chart. Okay, for question 5, show and explain the equation of the line through the given point that is perpendicular to the given line. The slope of the perpendicular line is a negative reciprocal of the slope of the given line if the given line is either vertical nor horizontal. Okay, so we did the exact same thing we did before. I used the values of negative 6 to 6. You plug them into the equation just as given, and this is what the points come out to be. You plug them into Excel, and it gives you the line of what blue would be, what it comes out to be. And we know that this is horizontal, and it's going downward. Okay, for question 6, if C is a circle with a center of C equals AB, and if Q is CD, then the equation of the tangent line is as shown below. Y minus D equals A minus C over D minus B, X minus C. The coordinates of the center of the given circle would be 0, 0. The coordinates of the point of the given circle would be 0, negative 6. Now we substitute the coordinates of the center and the point into the equation of the tangent line and solve for y. Okay, so we do y minus d over a minus c over d minus b, x minus c. So we plug in what we had, which was 0 and 0 and 0, negative 6. So we plug those in, we get y minus negative 6 equals 0. Okay, so when we solve for y and define the equation of the line that is tangent to the circle of the radius 6 at 0, negative 6, we go y minus negative 6 equals 0, which was right here. And so we get y minus negative 6. Okay, we recall that the coordinates of the center of the given circle is 0, 0. What is the coordinates of the point of the given circle? It would be 0, 6. We now substitute the coordinates of the center and the point into the equation of the tangent line that we were just using earlier, y minus d, a minus c over d minus b, and this x minus c. So we plug those in, and we get y minus 6 equals 0. But to solve for y, to find the equation of the line that is tangent to the circle of the radius 6 at 0, 6, we do y minus 6 equals 0, so y equals 6. So we know that both those lines, one was y equals negative 6, this one is y equals 6. So we know that the two lines are parallel. We can go ahead and draw this graph. It'll allow me. So we're going to draw this. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we knew that 1 was positive 6. So here we go. This is positive 6. The negative 6, because it's 0, you can go down negative 6. Okay, so then we know that they are both parallel. Parallel, parallel. This is negative 6. Okay. Stop that. Okay, so that's all I have for you today. I hope that you have learned something from my presentation, and I just want to thank you for watching my Math for Teachers 2 lesson 1. Thank you.